there! Welcome back to Head Start Learning. Today, we will unravel the concepts of resistance in series and parallel circuits. Let us first understand what is a resistance. A resistor limits the flow of charge in a circuit. The resistance in a circuit is shown by this zigzag symbol. The resistance is measured in ohms, symbolized by the Greek letter omega. Since resistors resist the flow of current, wires are made of metals with low resistance, so as not to obstruct the passage of the electrons. But resistors are made of materials that obstruct the passage of electrons to some extent, releasing the energy carried by the electrons, usually as heat or light. For example, a light bulb. Let us start with resistance in series circuits. In a series circuit, components are arranged in a line, one after the other. The total resistance in a series circuit is the sum of individual resistances. Total resistance in series is equal to R1 plus R2 plus R3. It is like a chain. The total strength is determined by each link. So the more the resistors you add in series, the higher the total resistance. It is a straightforward additive relationship. For example, if we have resistors with values 5 ohms, 10 ohms and 15 ohms in series, the total resistance would be 5 plus 10 plus 15, which equals 30 ohms. Now, let us switch gears and talk about resistance in parallel circuits. In a parallel setup, components are connected side by side, forming multiple pathways for the current. In a parallel circuit, the reciprocal of the total resistance is equal to the sum of the reciprocals of the individual resistances. If the total resistance in parallel is R, then 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. It might sound a bit complex, but it is like a team effort. Everybody contributes and the total resistance decreases. For example, if we have the resistors of 4 ohms, 5 ohms and 20 ohms in parallel, then 1 by R will be equal to 1 by 4 plus 1 by 5 plus 1 by 20, which is 10 by 20. Thus, the total resistance will be 2 ohms. As we can see, the total resistance in parallel is less than the smallest individual resistance. Let us try to understand resistances in series and parallel with an interesting analogy. The flow of charge through the wires of a circuit can be compared to the flow of cars along a tollway system. The main sources of resistance on a tollway system are the toll booths. Stopping cars and forcing them to pay a toll at a toll booth slows down the cars, just as resistance slows down the charge. Now, suppose that to increase the flow rate, the tollway authority decides to add 2 more toll booths. They consider 2 possible means of connecting their toll booths: in series versus in parallel. If toll booths were added in series, each car traveling along the highway would have to stop at each toll booth consecutively, with only one pathway through the toll booths. every car would be required to stop and pay a toll at each booth. Clearly, adding toll booths in series would increase the total resistance and decrease the overall car flow rate. Another way to add the 2 additional toll booths at this particular toll station is to arrange them in parallel. Each toll booth could be placed in a separate lane, allowing cars to stop at only one of the 3 booths. This setup would provide 3 possible pathways for cars to flow through the toll station, with each car choosing only one pathway. Clearly, adding toll booths in parallel would decrease the total resistance and increase the overall car flow rate along the tollway. Understanding these principles is fundamental to mastering electronics. I hope this video clarified the concepts of resistance in series and parallel circuits. If yes, then can you answer the following question? Which is the better way to connect lights and other electrical appliances in domestic wiring? Series circuits or parallel circuits, and why? A parallel arrangement will be a better way to connect lights and other electrical appliances in domestic wiring because a parallel arrangement has a low resistance. Also, in case of any short circuiting in one appliance, the other electrical appliances will remain unaffected. If you have any questions or want to dive deeper into any topic, drop a comment below. Don't forget to like this video and subscribe for more exciting science content. Until next time, keep exploring, keep learning.